August 1st, 2007, Minneapolis, 6:05 p.m. The I-35W bridge over the Mississippi River collapsed during rush hour. 13 people died. 145 are injured. The disaster makes international headlines. But here's what didn't make headlines. The replacement wouldn't just be built near the old bridge. The collapsed steel wouldn't be hauled to a scrapyard and forgotten. It would be salvaged, melted down, and recycled. The physical material of the disaster, eventually reused in construction across the region. The bridge that killed 13 people wouldn't simply disappear. Its steel would live on. And Minnesota would do something remarkable. Build the replacement in about the same time the original took, despite modern safety standards, environmental reviews, and winter construction. This is the story of how a city turned tragedy into resurrection, how disaster became an advantage, and how the dead bridge's steel became its successor's bones. The original bridge. The original I-35W bridge opened in 1967, the same year as San Diego Stadium. The same year as the Summer of Love. It was part of America's interstate highway system boom, the largest public works project in history. Designed by Sverdrup and Parcel, it was an 8-lane steel truss bridge spanning 1,907 feet across the Mississippi River. It carried 140,000 vehicles daily through the heart of Minneapolis. The design was elegant for its era, a deck truss configuration where the roadway sits at the bottom chord of the steel truss. This meant drivers looked through the structural steel as they crossed, a cathedral of industry above their heads. It cost $5.5 million to build. That's about $50 million in today's money. Construction took 2.5 years, from 1965 to 1967, standard for the time. But the bridge had a problem embedded in its DNA. The gusset plates, the steel connectors joining the truss members, were undersized, not grossly undersized, just enough to pass 1960s standards, but not enough for decades of increasing loads. Traffic got heavier. The bridge got heavier. In 2006, MNDOT conducted a resurfacing project that placed construction equipment and stockpiled materials, totaling hundreds of thousands of pounds, on the bridge deck. The added weight was supposed to be temporary. It wasn't temporary enough. August 1st, 2007, 6:05 p.m. The center span buckled, the deck twisted. The entire central section, over 1,000 feet, collapsed into the Mississippi River in less than 13 seconds. Cars, trucks, and a school bus all fell. Some plunged into the water, others landed on the riverbank or were crushed by falling steel. Minnesota was in shock. The I-35W corridor carried 140,000 vehicles daily. Rerouting that traffic would cripple the Twin Cities. The economic impact would be catastrophic. Governor Tim Pawlenty declared a state of emergency within hours. The question wasn't if they'd rebuild, it was how fast. The decision. Minnesota faced a choice. They could go through the standard federal procurement process, environmental reviews, design competitions, and multi-year approvals. Or they could do something unprecedented. On August 15th, just 2 weeks after the collapse, MnDOT announced an aggressive plan. The replacement bridge would be designed, approved, and constructed in 1 year. Transportation experts said it was impossible. Bridge projects of this scale take 3 to 5 years minimum. Environmental reviews alone can take 18 months. Winter construction in Minnesota? Forget it. MnDOT didn't care about the impossible. They issued a design-build contract with a massive incentive clause. Finish early, get paid $200,000 per day. Finish late, pay $200,000 per day. The contract went to Flatiron Manson, a joint venture. Their bid, $234 million. The clock started ticking. But MNDOT made another decision that would prove symbolic. The collapsed bridge's steel wouldn't be scrapped and forgotten. It would be salvaged and recycled. Every piece of recoverable steel was tagged, sorted, and sent to recycling facilities across the Midwest. There, it would be melted down and eventually reused in construction materials throughout the region. The old bridge wouldn't simply disappear. Its physical material would live on. The race against winter. Minnesota has 2 construction seasons, summer and other summers. Winter temperatures regularly drop below zero. The Mississippi River freezes. Concrete won't cure properly in extreme cold. Steel becomes brittle. Flatiron Manson had to finish the majority of structural work before winter shut everything down. They started with demolition. The collapsed center span sat in the river. Massive cranes pulled twisted steel from the water. Divers worked in near-freezing conditions to cut underwater sections. Every piece of salvageable steel was tagged and sorted. The structural steel, the truss members, the gusset plates, the beams, was sent to recycling facilities across the Midwest. There, it was melted down in electric arc furnaces at temperatures exceeding 2,500 degrees Fahrenheit. The molten steel was purified, tested, and recast into new structural shapes for use in construction projects across the region. Meanwhile, construction proceeded at breakneck speed. The new design was completely different from the original. Instead of a deck truss, engineers chose a post-tensioned concrete box girder design. This meant the roadway would be supported from below rather than suspended within a steel truss. Why the change? Safety, inspectability, and speed. Post-tensioned concrete could be built faster with modern techniques. It was easier to inspect, no hidden gusset plates, and it could handle Minnesota winters better than exposed steel trusses. The foundations were massive. Engineers drilled approximately 100 concrete shafts ranging from 5 to 8 feet in diameter, down to bedrock up to 100 feet below the riverbed. These would support the enormous loads. Then came the concrete pours. Some sections required continuous 24-hour concrete pours using over 1,000 cubic yards at once. Concrete trucks lined up for blocks. Crews worked in shifts around the clock. By November, winter hit hard. Temperatures dropped. The Mississippi began to freeze. But they didn't stop. Heated enclosures were built around active work zones. Concrete was mixed with special accelerators to cure in cold temperatures. Workers wore heated gear. The I-35W bridge project became the most closely watched construction site in America. Local news ran daily updates. National media checked in weekly. Engineers from across the country came to observe. Because this wasn't just building a bridge. This was proving that something could be done. The innovations. The new bridge incorporated technology that didn't exist in 1967. Sensors embedded throughout the structure monitor stress, temperature, vibration, and structural health in real time. If a problem develops, engineers know immediately. The bridge was designed to exceed modern flood resilience standards and includes seismic resistance features, despite Minnesota not being in a major earthquake zone. The engineers weren't taking chances. LED lighting systems illuminate the bridge at night with programmable colors. It's become a Minneapolis landmark. But the most significant innovation was speed itself. Flatiron Manson finished structural work in December 2008, just 16 months after the collapse. The bridge opened to traffic on September 18, 2008, 13 months and 17 days from collapse to opening. The original bridge took 2.5 years to build in the 1960s. The replacement took just over 1 year in the 2000s, with stricter safety standards, environmental reviews, and winter construction. How? Modern construction techniques helped. Prefabrication meant major components arrived ready to install. Computer modeling eliminated design errors before construction began. But the real answer was simpler: urgency. When 140,000 daily commuters are rerouted, when the entire city is watching, when financial penalties hit $200,000 per day, bureaucracy disappears. Flatiron Manson earned $20 million in early completion bonuses. They beat the deadline by over 3 months. The memorial. The new bridge isn't just infrastructure, it's a memorial. At the bridge's southern approach, Minnesota installed a memorial plaza. 13 stainless steel columns, one for each victim, stand illuminated at night. Water flows over black granite bearing the victims' names. The memorial isn't separate from the bridge, it's integrated into it, a reminder that the crossing exists because of those who died. There's something profound about this. The disaster that took lives led to immediate action. The steel that failed was salvaged and recycled into new purposes across the region. The site of tragedy became a memorial, integrated with a safe passage for millions. Family members of victims had mixed reactions to the speed of reconstruction. Some found comfort in the immediate action and permanent memorial. Others found the pace difficult as they grieved. The legacy. The I-35W bridge became a case study in rapid infrastructure response. When the Fern Hollow Bridge collapsed in Pittsburgh in 2022, officials studied Minneapolis as a model for rapid response. When the Francis Scott Key Bridge collapsed in Baltimore in 2024, rapid rebuild discussions emerged, though the circumstances were different. But here's what those comparisons miss. Minneapolis succeeded because the disaster created urgency that bypassed normal bureaucracy. Environmental reviews that usually take 18 months took 3 months. Design approvals that normally require multiple committees happened in weeks. The bridge was built fast, not because modern engineering is faster, but because the political and administrative barriers disappeared. That's not replicable without disaster. The I-35W bridge cost $234 million to build. The original cost $5.5 million, $50 million adjusted. That's 4 to 5 times more expensive, even accounting for inflation. But it's also a completely different bridge. Sensors throughout. De-icing systems, seismic resistance, designed for a 100-plus-year lifespan. The original was built to 1960s standards. The replacement was built to survive anything. On August 1, 2007, a bridge collapsed in 13 seconds. 13 people died. Minneapolis traffic ground to a halt. 13 months later, A new bridge opened. The old bridge's steel was salvaged and recycled into construction materials across the region. The replacement was built in roughly the same time as the original, despite modern regulations, built to standards that didn't exist when the first bridge was designed. The I-35W bridge that stands today isn't just a replacement, it's a response. The old bridge's material was recycled and reused. Tragedy became urgent. Disaster became the focus. And Minnesota proved something. When we remove the bureaucratic barriers, when we focus on solving the problem instead of following the process, infrastructure can move at speeds we've forgotten were possible. The question isn't whether we can build this fast. It's whether we're willing to treat infrastructure with the urgency it deserves before disaster forces our hand. So here's my question for you. Should we wait for bridges to collapse before we rebuild them aggressively? Or should we treat aging infrastructure with the same urgency Minnesota showed in 2007? Let me know in the comments. And if you want more stories about infrastructure built from its own ashes, subscribe. We've got more coming. Thanks for watching.